All right, ladies and gentlemen, review for Unit 9 test on probability. Before we get started, I just want to state that this test is not in the same format as the study guide. Okay, it is not in the same format as the study guide. But if you understand the study guide, you should be just fine for the test. In fact, the first part of the test, the first page, is multiple choice, and it's going to be based on knowing your rules. And you have to know the rules in this order because I'm going to give you a hint on the test. Hint, use rule number, like number 2, or hint, use rule number 3. If you don't have the rules memorized in the correct order, it's not going to probably be that easy. I'm trying to make it easier for you. So here we go. Rule number 1 looks like this. Rule number 1 is saying that all probabilities go from 0 to 1. You cannot have a negative probability. You cannot have a probability bigger than 1. All probabilities go from 0 to 1. Rule number 2. If you take all of the probabilities in a sample space and add them together, they should equal 1. They should not be less than 1. They should not be more than 1. They should equal 1. All of the probabilities in a sample space added together equals 1. Rule number 3. Rule number 3 says the probability of A or B, if you have that, you add the probabilities together. Again, or means to add. Rule number 4. Okay, a complement. That means like the probability that A will not happen. But we use the word complement and we put a little C on it. Again, a complement is like the probability that A will not happen. So to find that, you can take 1 minus the probability that A will happen. Okay, rule number 5. Okay, the probability of A and B. So if you want the probability of A and B, you multiply the two probabilities together. All right? So those are the 5 basic rules that you need to know. And you need to know which one goes with which number. Okay, I'm going to write that. Know by number. All right, let's go down to the spinner. All right, we're going to spin each spinner 1 time. Okay, how many outcomes are possible? Well, there are 3 on this spinner and 4 on this spinner. So how many outcomes are possible? 3 times 4, which is 12. All right, the next thing is list out all the outcomes. Okay, well, that's pretty easy. A1, A2, A3, A4, and continue with the B's. And continue with the C's. The next question, what's the probability of spinning in A3? Well, there's only one of them, so 1 out of 12. The probability of spinning a C, well, there are 4 of them out of 12, which reduces to 1/3. The probability of A or B, well, in this case, you don't have to add. You can just count them all up. So A, we've got 4 of them. And B, we have 4 of them. So that would be 8 out of 12, which reduces to 2/3. Please reduce. All right, the next one says a number greater than 2. Well, that would be 3, 4, 3, 4, 3, 4. That's 1, 2, 3, 4, 5, 6 of them. 6 out of 12, which is 1/2. All right, that's it for page 1. Let's go on to page 2. A college professor tells his class on the first day that there will be 3 tests in his class and 2 projects. He goes on to tell them that only 50% will get an A on the first test, 40% will get an A on the second test, and 30% will get an A on the third test. He then goes on to tell them that 70% will get an A on the first project, 20% will get an A on the second project. Assume each test and project are independent of each other. So, just because you get an A on the first test does not mean you're going to get an A on the second test. That's why they say they're independent. All right, so what's the probability of getting an A on all 3 tests? Well, remember, always change percents to decimals. Oh, I can't spell today. Let me fix that. Much better, okay? All right, so 50% would be 0.5 or 0.50. Now, that would be, this is an AND situation, so this is rule number 5. We multiply the 3 together. You get an A and an A and an A. Notice I'm using the word AND. So 0.5 times, or 0.50 times 0.40 times 0.30. So to get an A on all 3 tests, your probability is 0.06. Not very good. All right, the next one, what's the probability of getting an A on the 2 projects? Well, the first project is 0.70. And again, this is an AND situation, so we multiply, and the second project is 0.20. So the probability of getting an A on both projects is 0.14. What's the probability of getting an A on all 5 of them? Okay, well, that means I'm going to take the 0.50 times the 0.40 times the 0.30 times the 0.70 times the 0.20. I'm going to multiply all 5 of them together. And I'm going to get 0.0084. That's less than 1% chance. Not very good. Okay, so now the next one, this is where we're going to have to use the complement rule, rule number 4. Okay, so what we're going to do is we're going to rewrite this. So at least 1A. So I'm going to do 1 minus the probability that there is no A. You do not get any A's. Again, the opposite of at least 1A is 1 minus the probability of no A's. All right, so let's think through this. Really careful. Listen to my words. Again, listen, listen, listen. Let's switch this to a different color here. All right, so 1 minus. There were 3 tests and 2 projects. Okay, so the probability of getting an A on the first test is 50%. So not getting an A would then be 50% or 0.50. The second test, the probability of getting an A is 0.40. So the probability of not getting an A is 0.60. Okay, if 40% is getting an A, 60% is not getting an A. The third test, you got a 30% chance of getting an A. So that means not getting an A is 0.70. Then we have to do the two projects. 70% chance of getting an A, so that means 30% chance you don't get an A. And 20% chance you get an A on the second project, which means 80% chance you don't. So again, we took the opposite of getting an A for each one of those. So 1 minus that, okay, so that turns out to be 0.9496. Okay, let's move on. Number 3, create a Venn diagram. So suppose you have another professor that tells her class on the first day that there will only be 2 tests, a midterm and a final exam. There are some professors that do that. You got 2 tests, 2 shots at passing the class. And you must pass one of them to pass her class. She tells her class that only 70% will pass the midterm and 65% will pass the final exam, and that 40% will pass both. All right, so remember, Venn diagram, we're going to have, the situation calls for 2 circles. One will be the midterm, and one will be the final. Always start in the center. Okay, if you want to change your percent to a decimal, you can, but it is not necessary. I'll just leave it as a percent on this situation. So you always start in the middle. 40% will pass both. Now we have to fill in the other 2 circles, but we've already got a percent inside both circles. So we'll do the midterm. So we got to take 65%, nope, take that back, 70%. 70% pass the midterm. We already have 40% in the middle, so we have to subtract that, and we're left with 30% for the rest of the circle. 30 and 40 make the 70. Okay, same thing with the final exam. 65% will pass the final exam. We've already got 40% in there, so we have to take out the 40%. That leaves 25%. Now, I have to figure one more thing. Some people will not pass both. That'll be on the outside. Okay, well, to figure that out, I'm going to have to take my 3 percentages, add them together, and I get 95%. So that means there's 5% left. So that means that will go on the outside. Now, if you decided to do this with decimals, the decimal for 30% would be 0.3. The decimal for 40% would be 0.4. The decimal for 25% would be 0.25. And then the decimal for 5% would be 0.05. Again, if you'd rather use the decimals, go ahead. Otherwise, just use the percents on a Venn diagram. All right, so now the first question is, what's the probability you pass exactly one of them? So that means you either pass the midterm, which is 30% only, or you pass the final exam, which is 25%. So your chance of passing only one of them is 55%. That means only 55% of the students, well, no, I shouldn't say that. Let me reverse that. I won't say that. All right, let's go to the next one. Find the probability you pass only the midterm. Okay, well, that's the 30%. You pass only the final exam. That would be the 25%. You don't pass the class. Well, that would be 5%. 5% of the students will not pass her class. All right, let's move on to the next page. So now we're going to do a scenario, but we're going to do it with a tree diagram. Okay, the voters in a large city are made up of the following age groups. We've got 30% that are in the 18 to 29, 52% are in the 30 to 59, 18% are age 60 and over. Okay, then we have a mayoral candidate anticipates attracting 25% of this age group, 60% of this age group, and 45% of that age group. All right, so we're going to start with our voter. Now, we've got three age groups. We have the age group 18 to 29, and we must convert the 30% to a decimal. We have to use decimals on the tree diagram. Okay, 0.3. Then we've got the next age group, 30 to 59. And the decimal for 52% is 0.52. Then we've got the next age group, 60 plus, and 18%, 0.18, are going to vote for, or are in that age group. Now those three will add up to 100% or up to 1 as a decimal. Okay, so now we got to look at the votes. So in this age group, so either yes, they vote for the person, or no, they don't. So there's two branches, yes and no. Yes is 0.25, 25%. That means 0.75, what's left over, 75% would not vote for that person. Okay, the next one, again, two branches, yes, no. So in that age group, 60% will vote for the person, or 0.60, and that means 0.40 or 40% will not. And then in the last age group, yes, no. So yes would be 0.45, which means no would be 0.55. All right. Now, what I'm going to do is I'm going to multiply each of the branches together. So I'm going to take the 0.3 times the 0.25, and I'm going, for that branch, I'm going to get 0.075. In the next branch, I'm going to take the 0.3 times the 0.75. And I'm going to get 0.225. Okay, then in the next one, I'm going to take the 0.52 times the 0.60. I'm going to get 0.312. Then I'm going to take 0.52 times the 0.40. .208. Okay, and then the last one, I'm going to take the 0.18 times the 0.45. .081, and then 0.18 times 0.55. So what I did was I multiplied each branch together and found what that is. Now I can answer the questions. The answers should be in our tree diagram. What percent of the vote will come from the 18 to 29 age group? Okay, well, that's the very first one, 0.075. Okay, which is 7.5%. What percent of the vote will come from the 30 to 59 age group? Okay, that would be the 0.312, which is 31.2%. Then the next one, what percent of the vote comes from the 60 and over age group? Okay, that would be the 0.081 or 8.1%. What percent of the overall vote does the candidate get? Well, that would be the 7.5% plus the 31.2% plus the 8.1%. Okay, and that equals 46.8%. Based on the last percent, should the person win the election? No. Justify your answer. The person needs 50% more, I should say more than 50% to win. And they only got 46.8, so that person did not win. All right, let's keep going. All right, table. Using the table to find some probabilities. So first we're going to make fractions. Okay, if you would like to then make them into decimals and percents, that's fine. All right, here we go. So the probability that so we're dealing with male and female and then their favorite type of candy. Snickers, M&M Plain, M&M Peanut, and Reese's Peanut Butter Cup. All right, so female. So how many female are in this survey? So there are, what percent are female? So we've got 450 that are female out of the 970. Okay, and then you could go ahead and take that and make it into a decimal. Round it, let's go 3 decimal places, so 464, and then we can change it to a percent, 46.4%. Okay, I'll do it for the next one, but after that you can go ahead and type in and get the percents on your own. Okay, so M&M Plain. All right, well, M&M Plain, there are 105. It doesn't say male or female, it just says M&M Plain. So that's 105 out of 970. And the decimal for that is 0.108 or 10.8%. All right, the next one is a condition. Notice this line right here. That's a condition. So it's a male who likes Snickers. All right, well, let's see. A male who likes, that's 220. But I'm only interested in the ones that like Snickers. Okay, that would be 400 out of 420. So 220 divided by 420. So you can find the decimal on your own. Use your calculator. Okay, the next one, M&M Peanut, given that it is a female. All right, well, M&M Peanut, female. M&M Peanut, female. 40. And I'm only interested in those that are female. So that would be 450. All right. Female Reese's. Female rhesus. Female rhesus, 150. And I'm only interested in all of the ones from rhesus. 340. Okay, M&M plain given male. Okay, so M&M plain male. M&M plain male, 45. And I'm only interested in the ones from the male population, so that would be 520. All right. Number 6. You toss a coin 5 times in a row. How many outcomes are possible? Well, when you toss a coin, there are only 2 possibilities. There's heads or tails. Okay? So, you're going to toss it 5 times in a row. So again, you get heads or tails. That's 2. Heads or tails, heads or tails, heads or tails, heads or tails, heads or tails. So 2 times 2 times 2 times 2 times 2 times 2. Whoops, I got too many there. My mistake. There should only be 5 of them, not 6 of them. I had 6 of them there. Okay, 5 of them only. So 2 times 2 times 2 times 2 times 2. Okay, that would be 32. Wow, there are 32 possibilities. Now, the next one says flipping 5 tails in a row. So that would be like tails, 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 tails. That's it. There are no other ways you can do that. That's only one way. Tails, tails, tails. 5 tails in a row. That's only one way. 1 out of 32. Okay? Now the next one, we're going to have to list them, and it's not that bad. We're not going to list out all 32. We're just going to list out the situation that's given. Flipping 3 heads in a row. Well, that could be heads, 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 then tails, and then heads again, right? That's 3 in a row. Or you could just 3 in a row, not 4 in a row, just 3 in a row. You could go heads, heads. Whoops, no, hold on. Let me back. Whoa. Okay, you could go heads, 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 and then it could be tails, tails. Again, that's 3 in a row. Okay, now I might start with tails and then go heads, 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 tails. All right. Actually, let's change this problem. Okay, hopefully you're listening well. We're going to change this problem. Okay, we're going to take out in a row. This will make it a little easier. All right? So let's just say flipping 3 heads. Flipping 3 heads. All right, so I could do this. Heads, heads, heads. So only 3 heads. Tails, tails. Or it might go tails. Heads, 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 tails. It could go tails, tails, heads, heads, heads. So you'll know what I did. What I did there was I moved them over each time. Okay? So now here's another possibility. Heads, heads, tails, heads, tails. Heads, heads, tails, tails, heads. Okay, notice how I'm trying to keep a pattern to this. All right, now I'm going to go ahead and do heads, tails, tails, heads, heads. Then I could do heads, tails, heads, tails, heads. All right, so let's see. Now I could start off with tails, tails. No, I did that one already. Okay, I could do tails, heads, tails, heads, heads. I could do tails, heads, heads, tails, heads. And the last one would be heads, tails, heads, heads, tails. Okay? I think that's it. So that would be 10 of them. So 10 out of 32, or 5 out of 16. All right, next page. Remember A Princess's Love Story. All right, so we want to first figure out what's the probability of each path. Then we'll find out the probability of each room. So step 1, we got to write the probability of each path. So 3 paths, so this one's 1/3, 1/3, 1/3. Now right here, there's going to be 2 paths. So a half and a half. This one goes right into room Y. And then here, at this point, we've got a half and a half. So remember, we multiply the paths together. So this would be 1/6. Okay, 1/3 times 1/2 is 1/6. This would be 1/6. This one is 1/3. This one is 1/6. And this one is 1/6. Okay, again, multiply, just like we did on the other page. We multiply, except we have fractions, multiply them together. Now, for the room, we add them. So room X, (1/6) plus 1/6, and I would like the answer in fraction form. Use your calculator, use the fraction button. That's 2/6, which is 1/3. Okay, room Y, 1/6 plus 1/3 plus 1/6, okay, which is 4/6, or 2/3. So if you're thinking about the Princess Sophia and the love story, she should hide in room Y. Okay, next one. All right, so we have 4 paths. 1/4, 1/4, 1/4, 1/4. Right here we have 2 paths. 1/2, 1/2. 2 paths. 1/2, 1/2. 2 paths. 1/2, 1/2. 3 paths. 1/3, 1/3, 1/3. Multiply each of those together, so then this would be 1/8, 1/8, 1/8. Now there's 2 of them here. There's 1/8 for one and 1/8 for the other. Here it's 1/8. Okay, here it's 1/12, 1/12, and 1/12. All right, now there's 3 rooms, so we're going to add together. So room X is 1/8, 1/8. So you have a 1/4 chance of ending up in room X. Room Y, Add those up and you end up with 7/24. Use your calculator. 7/24. And then the rest of them are for room Z. Which turns out to be 11 out of 24. All right. And the review page. Okay, this should be super easy. Little geometry. The formulas are given to you. We've got the midpoint formula, the distance formula, and the slope formula. All right, so the first thing is the midpoint of AB. All right, so the midpoint of AB you would take 0 plus 4, those are the x values, and divide it by 2. Take the y values, add them together, divide by 2. So the midpoint of AB is 2, 3. The midpoint of BC. So take the x values for 12, add them together, divide by 2. And 6, 6, divide by 2. That gives us 8, 6. The distance formula of AB. We take the square root of. All right, take the second x value, which is 4, minus the first x value, which is 0 squared, plus the second y value, y2, 6, minus the y1 value, 0 squared. So that turns out to be the square root of 16 plus 36, which is the square root of 52. And if you take the square root of that, that's approximately 7.2. All right, the distance between B and C is the square root of. All right, the y2 value is 12 minus, the x2 value is 12 minus the x1 value, which is 4, and then squared, plus the y values are both 6, 6 minus 6 squared. That gives us the square root of 64, which is 8. All right, now the slope. The slope of AB. Okay, so the y2 value is 6 minus the y1 value divided by the x2 value minus the x1 value. So that would be 6 over 4. Reduces the 3 over 2. I'd like you to leave that as a fraction. Because remember, slope is rise over run. And finally, the slope of BC. Again, the y2 value is 6. The y1 value is 6. The x2 value is 12. The x1 value is 4. Well, 6 minus 6 is 0 over 8, which is 0. You could have figured that out without doing that because it's a horizontal line. Horizontal lines are always 0. All right, ladies and gentlemen, Again, the test is not in the exact format as the study guide, so make sure you look at it and study it and be ready.